Assalamualaikum warahmatullahi wabarakatuh to Sir Amirul and friend. In this slide, I want to explain about introduction of kinetic energy. There are many forms of the energy, including chemical energy, heat energy, electromagnetic radiation, nuclear energy, and rest energy. They are divided into two types: potential energy and kinetic energy. Kinetic energy is best understood via example of how it is changed into and out of the other type of energy. Uh, a cyclist, for example, will use chemical energy given by food to accelerate a bicycle to desired pace, except for overcoming air resistance and friction. This speed can be maintained with no further exertion. The energy has been turned into kinetic energy or the energy of motion, but the process is inefficient and heat is accrued within the cyclist. The kinetic energy is a moving cyclist and a bicycle may be transferred into the different form. For example, the cyclist may come upon a slope that is just high enough to cause up, causing the bicycle to come to complete stop at a summit. The kinetic energy has now been converted mostly to gravitational potential energy, which may be released by freewheeling down the other side of the hill. Because the bicycle lost some of its energy due to friction, it will never be able to reach its full speed without continuing pedaling. It's important to note that the energy has not been eliminated, rather it has been transformed to a different from via friction. Alternatively, the cyclist may connect a dynamo to one of the wheels and use the fall to create some electrical energy. At the bottom of the hill, the bicycle would be moving more slowly since part of the energy would have been redirected into the production electricity. Another option would be for the cyclist to engage the brake, in which case the kinetic energy would be released as a heat energy through the friction. The kinetic energy of an object like a physical quantity that is a function of the velocity. It is determined by the connection between the object and the observed frame of the reference. As a result, an object kinetic energy is not constant. Okay, thank you. That's all from me.
Assalamualaikum. Hi, my name is Muhammad Iqbal Nurkoin bin Sailin. I'm from Dimush 4A. Today, I would like to present about definition of kinetic energy. Kinetic energy is that the energy an object has due to its motion. If we wish to accelerate an object, then we must apply a force. Applying a force requires us to try to walk. After work has been done, energy has been transferred to the article, and also the object is going to be moving with a brand new constant speed. The energy transfer is true as Ke, and it depends on the mass and speed achieved. Kinetic energies and kinetic energy Kinetic energies are often transferred between objects and transformed into other forms of energy. For example, a pencil sharpener employs mechanical energy and electrical energy. Mechanical and civil engineers guarantee that that the that there is enough potential energy, which is converted to kinetic energy, to propel the car through the full roller coaster ride while building a roller coaster. This is example for kinetic energy: a spinning top and a rolling ball. Thank you.
Unit for kinetic energy. Hi, my name is Ismail Bezuhairi. My ID number is 1200903175, and I will present about unit for kinetic energy. Unit for kinetic energy in unit SI is joules. The symbol for joules is J. Joule is equal to work done by a force of 1 Newton through 1 meter. The SI unit joule are named in honor to English physi- physicist James Prescott Joule. For bigger scale, there are also kilojoule (kJ) and megajoule (mJ). 1 kg is equal to 1000 J, or 1 kilojoule is equal to 1000 joule, and 1 megajoule is equal to 1 million joule. That's all for unit for kinetic energy. Next presenter.
Okay, Assalamualaikum and greetings. My name is Muhammad Ashraf bin Wam and my student ID is 1200903190. And I will present about the brief history of kinetic energy. As you can see here, the kinetic word has its roots in the Greek language, which is kipnon, or also known as kinesis, which basically mean motion. Human inadvertently tapped into kinetic energy during the ancient time. So basically, as what you can see on the third sentence here, water wheel has been already been used in China during the first century of before Christ era. And for the third slide, there were two first Europeans to theorize the principle in classical mechanics of kinetic energy, and those two honorable persons are Gottfried Wilhelm Leibniz and Johann Bernoulli. All right. Those two, they describe the kinetic energy as living force or vis viva. Then a paper titled Du calcul de l'effet des machines was published by a notable author named Gaspard Gustave Coriolis in 1829. And around 1849 till 1851, a baron, basically a lord, named William Thomson was given credit for coining the term of kinetic energy. All right. In this slides, this is how the two famous Europeans in dealings with kinetic energy. This is Gottfried Wilhelm Leibniz, and this one is Johann Bernoulli. All right, that is all from me. Thank you.
Hi, my name is Mohammed Zafran bin Zaid from the Mosh 4A. I want to present about example of kinetic energy in daily life. This is my name and my ID number. Firstly, roller coaster. The more passenger on the roller coaster, the greater the kinetic energy of the roller coaster. Skateboarder. When a person rides a skateboard at rest, the coefficient for his energy is equal to zero. When the rider starts the movement, the kinetic energy coefficient will increase gradually. The fall of the vase. When when the vase falls out of place, it comes out of a state of rest into movement. When gravity amplifies its energy, the vase will begin to gain acceleration, and gradually that will give rise to kinetic energy in its mass. This energy is released after the vase touch the ground and break. Cycling. Cyclists who are at the starting point without doing any movement have a kinetic energy coefficient equal to zero. As soon as the cyclist start pedaling, this energy increase. The higher the speed, the greater the kinetic energy. And lastly, driving car. A stock car has energy equal to zero when his when this vehicle is driven and increase its speed, its kinetic energy coefficient increase so much so that the more speed there will be more kinetic energy. That's all from me. Thank you.
Hi, my name is Haris Azhar Trabinuddin, and I'm gonna continue the presentation. So, type of kinetic energy. So, the first one is thermal energy. So, the internal energy of an object due to the motion and collision of atoms and molecules is called thermal energy. Thermal energy is also called heat energy. All matters in the universe is made up of atoms or molecules. These atoms and molecules are constantly moving. We cannot see the movement of this energy with our eyes. Still, we can feel it when it touches our skin. For example, when you stand outside your house in sunny weather, you cannot see the heat from the sun. However, you can feel the heat. Thermal energy is produced when atoms and molecules move faster and collide with each other. The thermal energy of an object depends on the kinetic energy of atoms and molecules. In hotter objects, atoms will move or vibrate faster and have high kinetic energy. Therefore, they will produce more thermal energy. In contrast, in cooler objects, atoms have very little kinetic energy and they will produce less thermal energy like the other form of energy. Thermal energy is also measured in joules. So the next one is sound energy. Sound energy is a form of energy produced due to the vibration of an object. This energy can travel through any medium by transferring energy from other particles to another and can be heard when it reaches a person's ear. For example, when an object vibrates, it transfers its energy to the surrounding particles and make them vibrate. These particles again collide with each other particles. Similarly, sound energy will be transferred from other particles to another. Sound energy cannot move through a vacuum because a vacuum does not contain any particles to act as a medium. It only moves through mediums such as water, air, and solids. Very example of sound energy includes alarm, vehicle horns, thunderstorm, talking to people, drums beat, crackers, and other things. So the next one is electrical energy. The energy of moving electron is called electrical energy. All objects in the universe are made up of small particles called atoms. So these atoms are made up of very small particles such as electrons, protons, and neutrons. The electrons found in an atom are constantly moving around the nucleus of the atom. When an electrical field of external voltage is applied, the electrons present in the atom gain energy and break the bond with the parent atom and become free electrons. The energy carried by these free electrons is called electrical energy. So the last one is radiant energy. So electromagnetic radiant energy or light is called radiant energy, radiation energy. So this radiant energy is also called electromagnetic energy. This energy can travel through space or medium. As we know that kinetic energy is the energy of motion, radiant energy is always moving by traveling through space or medium. Therefore, it is a kind of kinetic energy. In general, anything that has a temperature emits radiant energy. For example, of radiant energy includes gamma rays, X-rays, ultraviolet light, visible light, such as purple, indigo blue, green, yellow, orange, and red. So infrared radiation, microwaves, and radio waves. The energy sent to the Earth from the Sun is also an example of radiant energy. This energy moves at a very high speed in a straight line. The energy of light or radiation may be visible or invisible to the human eye. Like the other form of energy, the SI unit of radiant energy is the joules. That's all for me. Thank you.
Okay, Assalamualaikum and greetings. My name is Muhammad Ashraf bin Wam and my student ID is 1200903190. So right now I will present about the kinetic energy calculation. This presentation will be the short one because there is a limited information about the calculation except for the equation and on how to calculate the kinetic energy itself. So let's go to the next slide. So, deep understanding of what is kinetic energy. Okay, kinetic energy basically depends on the velocity of the squared object, and it must always be either zero or positive value. The velocity of kinetic energy can have a positive or negative value, while velocity squared will always be positive. Last but not least, regarding kinetic energy, it is not a vector. Below is the equation for kinetic energy. As you can see here, below the previous sentence is the equation for kinetic energy. So if there is a calculation based on any kinetic energy related, this formula will be used. So basically, the Ke stands for kinetic energy, and mv sorry, my bad. Ke basically stand for kinetic energy, M stand for mass, and the unit is in kilogram, basically kg, and V stand for velocity, and the units for velocity is meter per second. That is all from me. Thank you.
Assalamualaikum. It's me again, Ismail Daniel bin Zuhairi. Now I will present about conclusion. Okay, the conclusion is kinetic energy is a form of energy that an object or particle has by creating a motion. If the transfer energy done by an object by applying net force, the object will gain kinetic energy. Kinetic energy are always be used in engineering, and kinetic energy also being used in wide variety of industry. Kinetic energy also being used in daily life, and everyone live with it. Now examples of kinetic energy. For engineering tools, kinetic energy are being used in power tools such as mechanical screwdriver, circular saw, router, jigsaw, sanders, and drill. In renewable energy industry, the first one, kinetic energy is being used in windmill. Windmill will converting wind energy to kinetic energy, and then convert it into electric energy. The second example is water dam. Water dam transfer the kinetic energy from the flowing water and convert it into electrical energy. Next is kinetic energy in daily life. The first one, the first example is fan. Fan converting electric energy to kinetic energy. The second example is car converting chemical energy to kinetic energy. The next one is swing converting potential energy into kinetic energy. That's all for the example. Now, conclusion for kinetic energy calculation. Kinetic energy calculation need to be learned and mastered by people that their occupation related with kinetic energy, and for the people that their occupation are not related to kinetic energy, knowing basic calculation as basic knowledge are useful for sometimes in their life, because kinetic energy always related to our daily life. That's all for my group presentations. Thank you.